Hello, and welcome to tonight's interactive stargazing. My name is Ariel, and I will be your interactive stargazing host. The telescope that we are using tonight is our 14-inch plane wave telescope with Cam software mounted onto it. So all of the images that you will be seeing tonight are live, taken as I'm talking about them, taken as you guys request them. So that being said, of course, as always, the viewers are able to request whatever objects we want to look at, and we can try to grab them to the best of our ability. Now, in Flagstaff tonight, it is a little cloudy and the moon is a little moony, but we're going to try our best to get some bright objects for you guys to view tonight, specifically binary stars or maybe the moon. We might be able to grab in a little bit. Now, to start off, the object that we are looking at is M40. Moon is, in fact, a little moony. M40 is a binary star system in the constellation Ursa Major, also known as Winnicke 4. Now, this binary is about 1,100 light years away, and we'll also actually see in this field of view right now, to the left, there are these two little smudges, and those smudges are actually galaxies. So we can see two NGC objects in the field of view there. NGC 4284 is on the left, and NGC 4290 is on the right. So we can see some of the galaxy's cores in there. Now, M40 is a binary that's not completely visible with the naked eye. And it's also not a true binary. So when we're talking about binary systems, that means like two stars close together. However, binary systems can be true binaries, meaning they are close together and orbiting each other, or they can only be visual binaries, meaning they look like they're really close together in the sky. They look like, they're a part of the same star system, but that doesn't necessarily mean that they're orbiting each other. Now, I see a request to see Mizar and Alcor in the Big Dipper. I believe that we will be able to grab those guys. Now, Mizar and Alcor are one of my favorite binaries. We've been looking at them a lot recently. Now, I believe these stars are actually in the handle of the Big Dipper, right there in the night sky. We can see using our plane wave system here. So binaries are really neat because when you're looking at the night sky just in general, chances are over 60% of the stars that you're seeing with your naked eye are actually multiple star systems. So the majority of the stars in our night sky, over half the stars in our night sky are multiple star systems. So two stars real close together, or even more stars real close together. Now, Mizar and Alcor, we might be able to grab some color difference in these guys. And that's kind of neat because what difference in color means in stars is if a star is more red or yellow or orange colored, it's a cooler star. Cooler is in 10,000 degrees Fahrenheit, 6,000 degrees Fahrenheit. And if it is a blue or a white star, it's going to be hotter, meaning it's going to be, could be 30,000 degrees Fahrenheit, a lot hotter than something like our sun, which is a main sequence star, and that's about 10,000 degrees Fahrenheit. So yeah, in this view here, we're able to see Mizar and Alcor. I believe the bottom star in the binary, the bottom star in the binary looks a little more blue to me, I believe. So we're able to see, it might also be because of the change in, or just because the clouds passing by, we might not be able to see a lot of color difference in our night sky up here. Normally the color differences in the stars will show us the temperature of the star, and that can also show us the age of the star. Normally, if a star is hotter or more blue, it's going to be younger. So a younger star, only a couple million years old, or maybe only a billion years old. And as a star ages, it gets cooler or more yellow. So that will make it, age what I just said there. It'll get older, cooler, and more red toned. I believe we have a request for M81 and M82. There are some clouds, but we may be able to grab him or grab them okay. We can start with M81. Now, M81 and M82 are the bodes and cigar galaxies. Now, these M objects that I'm referring to are objects in the Messier catalog. So in the Messier catalog, there are over 110 deep sky objects that this guy, Charles Messier, cataloged as not comets. The not comet catalog is the Messier catalog, but these Messier objects are some of the neatest deep sky objects and the easiest deep sky objects to find with an amateur telescope in our night sky. So wonderful, yes. So the Bodes Galaxy, we're adjusting our exposure right now. So Bodes Galaxy, we're able to see the core or the galactic, the core of the galaxy in there. So that is where that black hole is that's keeping together this giant galaxy. If we mess with the exposure, we might be able to make out some of the arms of the galaxy. Again, this is all being done live at the Gio Valley Open Deck Observatory at Lowell Observatory. So we are adjusting as we go. And again, feel free to try and request some deep sky objects. Nice, yeah. So that core is a little brighter now. We might be able to see two of the arms. I see one arm kind of on the left going up, and then one arm on the right going down, coming off of Bodes Galaxy. Now I see a request, or the request also asks for M82, which is the Cigar Galaxy. So both of these galaxies are pretty close together. In smaller telescopes, we're able to get both in the same, not smaller telescopes, certain eyepieces, certain telescopes, we're able to get both of these galaxies in the same field of view, which is fun. M82 is the Cigar Galaxy. So yeah. This guy, rather than being like face on, he's more edge on. So we're still seeing that galactic core, but it's not, looking at us like the yolk of an egg. This one is more edge on. So if we zoom in, we can actually see the bright galactic core. It's sort of being covered by some of nice, I like that. The galactic core is being covered by the star-forming regions and the gas in the galaxy, and we're able to see that it spreads from tip to tip. So we can see that the center of this streak in the sky is where that galactic core is, and as we get further and further away from the core, the stars are less densely packed, so it's not going to be as bright. So even though these, it looks like a smudge on the edges, those are individual stars. We are just not able to make out those individual stars with this telescope right now. Now I see a request for M61. We can try that one. So M61 is a spiral galaxy in Virgo. We definitely covered this guy in the Messier Marathon, but I can't remember what he looks off the top of my head. We can try for that one. I see neat. Yeah, so he's coming in. I think we might be able to up the exposure a little bit. Now, while we're on the topic of galaxies, we're messing with the exposure, and again, clouds may be kind of coming through, so it may look a little yellow at times, but we're still able to get some of the object in there. Spiral galaxies are younger galaxies, so we're seeing more star-forming regions. We're seeing more gas, like in the Cigar Galaxy as well as in Bodes Galaxy. We're seeing more darker regions or spiral arms. In those arms and in those darker regions, we have a bunch of star forming happening. Oh, nice! We're able to see the spiral arms in this sky. It looks like a little. I think of like that scene in Nemo with the little octopus kind of twirling around. That's what spiral galaxies look like to me. So I don't know if y'all know what I'm talking about, but if you do, you won't be able to unsee it. So you're welcome. But yeah, and here we can see the core. We can see all of those star-forming regions and these spirals, those really bright areas. The brighter dots in this spiral galaxy in M61 are most likely dying stars or stars exploding, super energetic, very hot areas in M61 in this view here. So I see a request for M51. M51 is one of my favorite galaxies, might be my favorite galaxy, maybe tied for first with like some other galaxy I can't think of right now. M51 is the Whirlpool Galaxy. So again, there are some clouds, but I think we might be able to grab this guy. Now, the Whirlpool Galaxy, looking at the Whirlpool, we'll actually be seeing galactic cannibalism. So there's M51A, so this normal spiral galaxy, and then there's M51B, which is a smaller, kind of like a funkier galaxy. That is the core of M51A right there. And what's happening is, since one of those galaxies is more massive, it's like more powerful. It's a gravitational bully. So he's going to try to eat the smaller galaxy, like the most metal thing I've ever heard of. And as we up our exposure, we can see down there we're taking a 30-second exposure at the bottom of the screen. We may be able to grab more of the center of M51. But were we okay? Yeah. Yeah, more of the center of M51. And yeah, we're going to try to take another 30-second exposure. The field of view looks a little kind of cloudy or a little fuzzy right now, again, because clouds are passing through, and the moon is in fact a little moony tonight. So we're still trying to get the most light we can with these objects. Also, I totally just lied to you. The object that we were looking at was M61 still. That is M51. The telescope didn't move. So M51, this one's we can actually see what I was talking about. I don't sound crazy anymore. So we can see that there's these two brighter objects in the field of view. The one on top, we can see those spiral arms kind of coming in. And then the galaxy on the bottom is getting eaten by the one on top. However, the galaxy on the bottom is putting up a fight. We can see the spiral arm in the upper left of the top galaxies, kind of a perfect spiral. But the spiral in the bottom right is kind of turning into like a square just above that little galaxy there. So little galaxy is trying his best, but he's most likely going to get sucked in to M51A, the more massive galaxy. So something like this is going to happen to us in like 5 billion years. The Andromeda Galaxy is coming towards us at like 80 miles a second. And when we collide with the Andromeda Galaxy, it'll take like a couple billion years to actually mishmash all of the star bits and gas bits. But that will... it'll be a pretty cool light show, and that'll happen around the same time our sun is set to explode. So that'll be a fun little party in our solar system. So I see request for a spiral galaxy. We've been looking at some spirals. So M51 here is a spiral galaxy. And M61 that we were looking at earlier was also a spiral. So we're able to see the little kind of octopus arms coming out of these galaxies. I also saw a question of how many light years are Mizar and Alcor from each other. They're about 3 light years from each other. Now I see a request for Mars. So we can definitely jump on over to Mars. Now he is setting in the sky. Is the telescope going to put up a fight? I don't think so. I think we may be able to try. Mars has been really popular in the news recently. I believe Ingenuity, the little Martian helicopter, just took its first flight or test flight yesterday. Yeah, Tuesday morning. So congrats to JPL and the Perseverance team and all that stuff. I love space robots. I think they are just the coolest things humans have ever done. So yeah, we're switching over to video mode here because Mars is really bright. Mars is a very bright object. So with things like planets or bright stars, we don't want to take a giant exposure or like a 30-second exposure because we'll just kind of blow out the image. But here we're able to see some of the orange tint to Mars hanging out on the screen there. Um, yeah, cute little guy. I like him. Yeah. Again, Perseverance is doing some really cool stuff. Perseverance landed on Mars, I want to say like last month, pretty recently. And that little rover was sent to Mars to find like concrete evidence of ancient life on Mars's surface, which I think is one of the neatest things ever. I love aliens. And if you say you don't like aliens, you are lying. And Ingenuity is we've never done something like that before. Ingenuity, as I mentioned earlier, is the little helicopter on the surface of Mars, and we've never had a little drone. We've never flown a little helicopter around on another planet before. So we're making history as we speak, which is the coolest thing ever. I love robots, and I'm going to keep saying that because robots are so neat, and humans are so neat for making robots. Mars is also, pretty special to us here at Lowell Observatory because Mars is the reason why we were founded way back in 1894. So we were founded to actually find the aliens on Mars. So we tried, but now they're actually going to Mars and they're doing it. So I'm pretty excited. Now I see a question. This is my first time here. Hello, welcome. What are we able to see? All kinds of stuff. Right now we're looking at Mars. We've been looking at spiral galaxies. We can see binary star systems, maybe some star clusters. Again, as I've been sort of mentioning, there are some clouds sort of passing overhead in Flagstaff, but we're trying to grab as much as we can. I see a request for M16. That sadly is below the horizon. I wish we could. And then I see another request for NGC 4731. So this guy is a spiral galaxy in the constellation of Virgo. So we've been jumping in and out and all around spiral galaxies in the sky tonight. But yeah, we're going to up the exposure and we're going to see what kind of spiral this is. When you're looking at spiral galaxies, there's normal spirals where we see the core and then we see the arms sort of coming out of it. And then sometimes we'll get barred spiral galaxies. And what that means is rather than, the core and then the arms coming out, we'll actually get the core and kind of like a line or a bar going through the core. And then we'll get the arms coming out of the core of the galaxy. So the ones that we've been looking at are not barred spirals. There's spirals, but they still look pretty neat. Now there are clouds passing overhead. So this guy looks a little fuzzy, but we are able to make out some of the body of NGC 4731. So we can see the core in there and just a little bitty bit of the gas and the star forming regions in this galaxy in Virgo. I see a request to view the moon. I would love to view the moon. The moon never gets old. So I believe the moon's about half full tonight. So we'll be able to see some of the details in the craters. It's nice when the moon isn't completely full because we can actually see, the depths of these craters on its surface. When it's a full moon, it's still pretty, but it looks more so like a piece of paper, like a drawing. Here we can see, these craters are miles across and miles deep as they go across the moon's surface. So with this object, we're going to switch on over to video mode again so we don't blow out our eyeballs. Wonderful. Wow, he looks nice. Cool. So nice. Yeah, in this guy, we can see those craters as well as the lunar Maria. Oh, we can also see some clouds passing through. The shadows that we're seeing right now are clouds passing in front of the moon. So on the moon's surface, we see those darker regions. That's called Maria or lunar mare. And that is evidence of ancient volcanic eruptions. So when the solar system was first forming, there were these giant impacts, giant space rocks smashing into the moon. And the moon at the time was covered in these effusive volcanoes, or really kind of mellow, light, low magma flows. And this molten rock filled in these impact craters and hardened a darker color than the rest of the surface of the moon. So that's why we get these darker circles, these darker craters, and we see like people say they see like, oh, the face on the moon, or like the horse or the rabbit on the moon, or like the man on the moon. You can't see the man on the moon, but like a face of a man on the moon. I've never been able to see any of those things, but if you can, I'm jealous, and I stare at the moon all the time. And I haven't been able to see these images that people say they see. But again, I like looking at the moon when it's not totally full. This is around the perfect time. I love looking at the moon because we're able to see those impact craters like in the northern area of the moon, as well as the Maria in the southern area from our field of view here. I believe around the middle, the bottom middle there is the Sea of Tranquility, around where we landed on the moon over 50 years ago. Now I see another request to look at Uranus. Now that guy is below the horizon, so we are not able to grab him right now. And I see another request to view the Sombrero Galaxy. So we can jump on over to that guy. Again, it is cloudy, but we may still be able to grab them. We've been able to grab bits and pieces of the other galaxies. So I have hope. I say that now. The Sombrero Galaxy is neat. So it's another edge-on galaxy. So we're going to be seeing the galactic core and then this sort of darker stripe going through it. It's a really like a nice, well-structured galaxy. And that darker stripe is where that galaxy formation, or sorry, the star formation is happening. So yeah, we are putting the exposure to 10 seconds. We may be adjusting the exposure a little bit. Yeah, little guy, there he is. Little dude. So yeah, we can see the core there, that supermassive black hole that's keeping together the galaxy. And then we can see the stripe going through it, which is just really dense, primarily hydrogen gas that's helping form little baby stars that are hanging out in the galaxy. Now I see requests for Arcturus or Sirius. Let's try jumping over to Arcturus. Now, Arcturus is a pretty red star in the sky. It's a red star in the constellation Bodes. I think it's kind of like the belt of Bodes, the herdsman. Now, I like looking at stars with an exposure like this because we are able to see that twinkle that we see, that sort of cross going through the star. That's actually the secondary mirror in reflecting telescopes. So how this plane wave works, the 14-inch plane wave that we're using tonight works, is there's a 14-inch primary mirror at the base of the telescope, and then there's a smaller secondary mirror kind of at the end or the middle of the telescope. So the light of the object that we're looking at will bounce off the primary into the secondary, and then in a hole through the primary into the eyepiece or the instrument port. So right now it's bouncing into this instrument port, but the secondary is being held in to the middle of the telescope, and it's smaller by these little prongs. So the little twinkle that we see in the star is actually from the mirror. Little mirror prongs, yeah. Arcturus is also a pretty easy star to find in the night sky. How I like to find him is you find the Big Dipper, which is one of the easiest things that you can find in the night sky, and you take the arc of the Big Dipper, and you're able to. Ooh, can we show it? Ooh, yeah, we can take the arc of the Big Dipper and just kind of keep going along the arc, and you go arc to Arcturus. So. Yeah, little guy right there. So we can see, the arc of the Big Dipper near like M101 is pointing straight to Arcturus in Boetes. Sirius is also visible in the sky tonight. We actually might be able to grab some color difference in these guys because Arcturus is more of a red star. And Sirius is pretty blue in the night sky. Sirius is the neat star. Sirius is the brightest star in our night sky, the most bright star. in our night sky, and he's about, yeah, he looks a lot more blue-white than Arcturus does. Sirius is about 9 light years away. Sirius is also known as the dog star. It's the brightest star, not only in the night sky, but also, of course, the brightest star in the constellation Canis Major, one of Orion's hunting dogs. It also rises around the same time that weather starts to get a little warmer here in the northern hemisphere. So that's where the dog days of summer comes from, the dog star. Now I see. We still have a couple minutes, so let's try and jump over to Castor. So Castor is one of the brightest stars in the constellation Gemini, one of the inferior zodiac signs. But Castor is interesting because it is a binary star. So the Gemini twins, the two, Gemini is like one of the constellations in the night sky that actually looks to me like what it's supposed to look like. Like it looks like two little stick figures holding hands in the night sky, and the star Pollux is the head of Pollux, and the star Castor is the head of Castor. Nice little dudes. Yeah. So in this view here, we are seeing Castor. So Castor is actually two stars real close together, kind of, going about each other as they live, I suppose. But it's cool to see, a star that you may see every single day or every single night, I suppose. And it's actually two separate stars that are hanging out in our night sky. Now, it is 8:57. If you guys have any last minute requests, I would love to try to grab them for you. If not, we can try to jump on over to M46, if that is visible in the night sky. I believe it is. Yeah. So M46, I love looking at open star clusters in every single telescope I've ever looked at them through. So I love looking at them through this telescope, the plane waves, because we're so zoomed in, we're taking longer exposures. So not only do the stars look like brighter, but we're also so zoomed in that we're seeing not enough of the open cluster. So we're looking into like a smaller kind of like the core of this open cluster. Oh yeah, and this cluster is really cool because there's that little star with the little sort of halo, the little ghost around it. That is a planetary nebula. So that is actually the death of a sun-like star. So we can see this giant, field of stars here. And then kind of in the middle of the view, we see what our sun's going to look like in like 5 billion years. So that's fun. I love this field of view here. Now, I see a question to view the North Star. However, with where the telescopes are, where the telescopes are, we actually aren't able to go and point them we can't point the 14-inch plane wave that we're using tonight at the North Star. It's like directly above the building that we push back to view whenever we're going out and viewing. Yeah. Yeah, I love planetary nebulae are very interesting because, that star, it's burning its hydrogen fuel for billions of years. And once it runs out of hydrogen, it's going to start fusing helium. And then when it's done fusing helium, we're going to keep fusing elements until there's no elements left. And when it starts fusing anything that's not hydrogen, I kind of think of it as like stars sort of like having like an allergic reaction or like kind of bloating because that star is getting a little bigger. And then once there's nothing else for that star to fuse, it's going to sort of explode. And we're going to see lighter elements because this was the death of a lighter star. So that just about ends our interactive stargazing here on YouTube for tonight. Now, we also do interactive stargazing over on our Twitch channel, and I believe That may be starting in a little bit as well. So a little more sort of laid back. I believe we have 2 hosts hosting our interactive stargazing over on our Twitch channel. So if you guys would like, you can totally feel free and check that one out. But with that, that just about wraps up tonight's episode of Interactive Stargazing. So thank you guys so much for coming and hanging out, and thank you for the awesome, thank you, telescope operator. Thank you for the awesome requests, and we will see you soon. Have a good night.